Crude oil is transferred from the drilling facilities or the oil wells to the refineries in order to be processed to produce marketable products. Refining is a series of complex physical and chemical processes. The process begins with the heating of crude oil, which subsequently, in the form of a hot mixture of gases and liquids, is fed to the atmospheric distillation tower. The different components of the crude oil separate, depending on their boiling point under atmospheric pressure. The light components, or fractions, rise to the top of the tower, while the heavier ones drop to the bottom. The various fractions are fed to other facilities or units for further processing, in order to make products suitable for consumption, complying with the pertinent specifications. Naphtha, which is the lightest fraction of the atmospheric distillation, is collected from the top of the tower. Naphtha is used as raw material for the production of plastics and fuels. By hydrodesulfurization, sulfur is selectively removed from naphtha through its reaction with hydrogen at high pressure and temperature. Subsequently, the desulfurized stream is directed to the reformer. There, naphtha is transformed to gasoline through a catalytic process, where the straight hydrocarbon chains are cyclized, increasing octane number. Hydrogen, which is a byproduct of the cyclization process, is used in other processes of the refinery. The first side fraction of the atmospheric distillation tower is kerosene, a particularly flammable fuel. In order to improve its quality, sulfur compounds are removed through washing with sodium hydroxide. The final product is used mainly as jet fuel, as well as lamp oil. Heavier fractions such as diesel oil follow, and through a desulfurization process with the use of hydrogen, are cleaned from sulfur compounds, resulting in the production of a much more environment-friendly fuel. The solid sulfur produced from the desulfurization process is used by chemical industries and in the production of fertilizers. Diesel oil is used as motor and heating fuel. The heaviest product of the atmospheric distillation is fuel oil, which is used as fuel in ships and in industry. It can be transformed to high-value products by further separating into heavy and light fractions with vacuum distillation in order to avoid extremely high boiling temperatures. In this manner, the energy requirements of the production process are reduced and the stability of the products is ensured. This procedure produces heavy diesel oil and asphalt or heavy fuel oil. Heavy diesel oil may subsequently be upgraded to high-quality diesel oil through hydrocracking, during which the large carbon chains are broken or cracked to smaller ones with the aid of hydrogen under high pressure and temperature. An alternative procedure is the fluid catalytic cracking, where the maximization of naphtha production from heavy diesel oil is achieved. In both cases, liquefied petroleum gases known as LPG are produced, which then react with sodium hydroxide to remove the sulfide compounds. Subsequently, they are marketed independently, either as final products or as a mixture of propane-butane for use in gas cylinders, greenhouses, and as motor fuel. The heavier fraction is subjected to visbreaking in order to reduce its viscosity, with a parallel slight transformation to lighter fractions. Alternatively, it may be subjected to cocking, during which it is transformed to lighter fractions, mainly fuel gases and diesel oil. Through special processing, heavy fractions can produce raw materials for lubricants and paraffin. Not all refineries are equipped with all the aforementioned units. The degree of complexity defines the final products and the efficiency of the procedure. Hellenic Petroleum owns state-of-the-art, safe refineries which render the company one of the most competitive energy groups in the area of Southeast Europe.